our program is talking about the type of steels. My name is Daniel Hernandez.
I'm Mirza Pascual.
And this is the introduction. Carbon steel is steel in which the mining interstitial alloying constitute in carbon in the range of 0.12 to 2%. The American Iron and Steel Institute defined that steel is considered to be carbon steel when no minimum content is specified or required for cobalt, nickel, titanium, or tin chloride, or any other element. Elements thus excel the percentage notes. Manganese 1.75, silicon is about 0.70, and copper is about 0.7.
The term carbon steel may also be used in references to steel which is not stainless steel. In this use, carbon steel may include alloy steels. As the carbon percentage content rises, steel has the ability to become harder and stronger. Through heat treating, however, it becomes less ductile. Regardless of the heat treatment, a higher carbon content reduces weldability. In carbon steel, the higher carbon content lowers the melting point. Classification of carbon steel. Low carbon steel are cheap, bendable, corrosive. The concentration of carbon steel in low carbon steel is less to 0.3%. Mechanical properties. The low carbon steel have excellent formability and weldability. Their general uses: sheds manufacturing, piping and pressure vessel components.
Low carbon steels. We have so many examples. For example, this one is very bendable. If you can see, you can to mold. And we have two objects to chip. For example, clothes. The clothes are very cheap. You can see. And talking about corrosive. Corrosive, for example, if you can see, this material is very corrosive. And is very cheap too. And that's it to the low carbon steels.
Medium carbon steels. Medium carbon steels are also cheap, strong, semi-weldable. Their carbon steel and medium carbon steel are between 0.3 and 0.5%. Mechanical properties: balances ductility and strength, and has good wear system. And the general uses used for large parts, forging, and automotive components.
Okay, in this case we have some examples. If we need to talking about the chip, we have, for example, these tools for mechanical tools. These are so cheap, and if we need to talking about the strong, we have these things are very strong. If you can use, you can see the strong. And semi-weldable. The semi-weldable is like kind of chain. You can see it's semi-weldable because in the middle of the wheel of each wheel is semi-weldable.
High carbon steels. High carbon steels are not corrosive, are strong, and have wear resistance. The carbon on high carbon steels are between 0.6 and 2%. Mechanical properties: they have high strength, low ductility, poor weldability and formability. The general uses used for springs and high-strength wires.
Okay, the examples of the high carbon steels. For example, for non-corrosive we have, for example, this kind of thing. You can put water in this kind of thing, and this is non-corrosive. Now we're talking about the strong. Strong is like kind of this hammer because it's very useful for to work very hard, and we're resistance. We can talking about this one that is a one part of the card is part of the card and it's very weird resistance. And for example, this one is to wear resistant too because it's for to work very hard.
Heat treatment in carbon steel. Full annealing. Carbon steel is heated to approximately 4 degrees Celsius above AC3 and AC1 for 1 hour. This ensures all the furate transforms into osmate, approximately 4 degrees Celsius above AC3 and AC1 for 1 hour. This ensures all the furate transforms into osmate. The steel must be cooled slowly into around 20 degrees per hour. Usually, it is just furnace cooled, where the furnace is turned up with the steel. Usually, it is just furnace cooled, where the furnace is turned up with the steel inside. This results in coarse paralytic structure, which means the bands on perlated peak. Purely annealed steel is soft and ductile, with no internal stresses, which is often necessary to cost-effective forming. Only periodized steel is softer and more ductile.
Normalizing. Carbon steel is heated to approximately 5 degrees Celsius above AC3 or ACM for 1 hour. This ensures the steel completely transformed to Einstein. The steel is the high cool and which is cooling rate approximately 38 Celsius per minute. This results in a fine parallelistic structure and more uniform structure. Normalized steel has a higher strength than annealed steel. It has a relative high strength and hardness.
Mark tempering is not actually a tempering procedure, hence the term. It is a form of isothermal heat treatment applied after an initial quench of typical in a molten salt bath at a temperature right above the Mark-Distinct start temperature. At this temperature, residual stresses within the material. At this temperature, residual stresses within the material are relieved and some pinite may be formed from the retained austenite, which did not have time to transform into anything else. In industry, this is a process used to control the ductility and hardness of a material.
Tempering. The tempering process is the same as Mark tempering process, except that the steel is held in the molten salt, but the pinite transformation temperatures, and the moderately cool. The resulting pinite steel has a great ductility, higher impact resistance, and less distortion. The disadvantage of the tempering is it can only be used on a few steels, and it requires a special solvent. Okay. Now we're talking about two companies that these companies have been produced steel here in Guatemala. One of these companies is ASA. ASA was founded in 1996 and having the vision of supply the Guatemala market, reinforcing the steel bars. That has been important until that moment.
Aceros de Guatemala begins the operation as individual enterprise dedicated to cloth production and now is the bigger distributor of steel in Guatemala.
Okay, that's it about our project, and we hope that you appreciate our project and our work, and that's it. Thank you.
Thank you very much.
We needed somebody to lean on.